Welcome to my first video. My name is Alejandro Gonzalez and I will be your teacher today. The topic we're going to talk about today is parametric equations. The objectives of this class is to make you understand, first, the use of point plotting to graph plane curves described by parametric equations. Second, eliminate the parameter. Third, find parametric equations for functions. And finally, understand the advantages of parametric representations. But first, what is a plane curve and a parametric equation? Suppose that t is a number in an interval. A plane curve is the set of ordered pairs x and y where x equals f in function of t and y equals g in function of t in interval. The variable t is called a parameter and the equations x equals f in function of t and y equals g in function of t are called parametric equations for the curve. But now, how do we graph plane curves? First, select some values of t on the given interval. Second, for each value of t, use the given parametric equations to compute x and y. And finally, plot the points x and y in the order of increasing t and connect them with a smooth curve. Okay, now that you know what are plane curves, parametric equations, and how to graph them, I'm gonna explain you an example. Example 1. Graphing a curve defined by parametric equations. Graph the plane curve defined by the parametric equations x equal t squared plus 1, y equal 3t, minus 2 less than or equal t, and t less than or equal 2. First step, select some values of t on the interval. Let t equal minus 2, minus 1, 0, 1, and 2. Now, step 2. For each value of t, use the given parametric equations to compute x and y. In the first column, we have the t, all the values that we say before. Now, on column 2, we have the formula for x, on the column 3, we have formula for y, and on the column 4, we have the values of x and y. For example, we can use the value of t, we can use 1 right here, and if we add that number 1 on the formula of x, we have 1 squared plus 1, so we have 1 plus 1 equals 2. Now, on the formula for y, we can add it like 3 times 1 equals 3, so we have 3. And on the values of x and y, we got 2 and 3. And the same for all of the numbers. And step 3. Plot the points x and y in the order of increasing t and connect them with a smooth curve. So first we have t minus 2 first, this point, then it goes increasing, t minus 1, 0, 1, and 2. And you mark a curved line. Now, how do we eliminate the parameter? If we eliminate the parameter in a set of parametric equations, we can write one equation in x and y that is equivalent to the two parametric equations. Eliminate the parameter t and graph the resulting rectangular equation in x and y. It may be necessary to change the domain of the rectangular equation to be consistent with the domain for the parametric equation in x. Next example. Example 2. Finding and graphing the rectangular equation of a curve defined parametrically. Sketch the plane curve represented by the parametric equations by eliminating the parameter. X equals 6 cos t, y equals 4 sin t, p less than or equal to t, and t less than or equal to 2p. We eliminate the parameter by applying the identity. Cos squared t plus sin squared t equals 1. X equals 6 cos t, y equals 4 sin t, cos t equals x over 6, sin t equals y over 4, cos squared t equals x over 6 squared equals x squared over 36. And sin squared t equals y over 4 squared equals y squared over 16. Second step. So what we do here is applying the identity by adding x squared over 36 plus y squared over 16. And that identity is cos squared t plus sin squared t equals 1. That's why x squared over 36 plus y squared over 16 equals 1. Finally, on the last step, we do as same as the last example. We plot all the points. So, how do we find parametric equations? Parametric equations for the function y equals f in function of x. One set of parametric equations for the plane curve defined by y equals f in function of x is x equals t and y equals f in function of t, in which t is in the domain of f. And the last example, example 3, finding parametric equations. Find a set of parametric equations for the parabola whose equation is y equals x squared minus 25. Let x equals t. Parametric equations for y equals f in function of x are x equals t and y equals f in function of t. Those parametric equations for y equals x squared minus 25 are x equals t and y equals t squared minus 25. Okay, so now we're gonna make some problems in a program called Math Excel. So, the first problem says, find the order pair that corresponds to the given pair of parametric equations and value of t. So, in here we have our true formulas and our value for t. The only thing we're gonna do is to substitute this value on the t of the formulas. So we have 3 times 3 plus 4 plus 4 that equals 13. So our first value is 13 and our second value is minus 3 times 3 times 3 plus 1 that equals minus 8. So our second number is minus 8 and the answer is correct. Let's go to the next question. Okay, second problem. The second problem says, use point plotting to graph the plane curve described by the given parametric equations. Use arrows to show the orientation of the curve corresponding to increasing values of t. So we have our two formulas of x and y and our values that are from minus 2 to 2. So we need to substitute. The first one is minus 2 oh minus minus 2 plus 12 and is 10. That's our x. And minus 2 squared is 4. We get 4, I think. Yeah, we get 4. So we need to find where is plot 10, x, and y 4. Let's see. 10, 7, 8, 9, 10. 1, 2, 3, 4. Okay. The first point is correct, so we have these two options. These two options can be because they're negative. Okay, next point, minus 1. Minus 1. Oh, minus 1. Okay. Oh, why it doesn't work? Okay. Minus 1 plus 12, 11, and minus 1 minus 1 squared, that is 1. Okay. So we need to find that point, that is 11x, and x is equal to 11 and y is equal to 1. Both of them are correct, but this one, we can assume that this one is increasing this way, this one is increasing the other way, so we need to choose the one that is increasing correctly. And so this is minus 2, this one is minus 1, so this one will be 0, 1, and 2, and it will increase. So this one needs to be the correct answer. Okay, it's correct. Let's go to the next question. Third example. This is a bit harder, so the question says, in the following exercise, eliminate the parameter t. Then, use the rectangular equation to sketch the plane curve represented by the given parametric equations. Use arrows to show the orientation of the curve corresponding to increasing values of t. What we need to know is that x is equal to t, that is here, it says here, x is equal to t, so we know that y equals 8x. And we know that minus infinite is less than t, and t is less than infinite, so it could be any number. And that's why we know that there are no restrictions on the values of x and y. There are no restrictions. So we know that y equals 8x, and it doesn't have restrictions. So let's see if it's correct. It's correct. And now we need to see if, okay, we need to graph it. We need to see if the values are correct. So okay, so now we're gonna use the common values -1, 0, and 1 to identify which of these graphs is the correct one. So we know that y equals 8x. We can substitute x with -1, so -1 times 8 is -8, so we need to find -8, -1 of x, and -8 of y. So this one is correct. This one is not correct because it's decreasing. It's the same with this one. This one is inverse. And also this one is inverse. So let's see if we put a 0 in x0, y is equal to 0, so it's on the same point, all of them. And if we use 1, x equals to 1, 1x, 8, and y will be 8. So 1x, and it will be 8. So this one will be the correct one. Yeah, let's go to the next question. Okay, this is the next question. It says, eliminate the parameter, then write the resulting equation in standard form for the given situation. So we know that it's a circle, and its formula is x equals h plus r cos t, y equals k plus r sin t. So we know that the formula of the circle for parameters is x and y on both of the parentheses, minus on both of it, and you used both of the first letters that appear on the equation. And the first one says h, and on the other one k. And this one's plus, and both of these equals the the radio of the circle squared, and both of these are squared. And this question is correct. Next question. Okay, this is the next question. It says, find a set of parametric equations for a circle centered at 8 for x and 4 for y, with a radius of 6. Choose the correct set of parametric equations which describe the circle. Now we need to use the formula that was before. So we know that this one is the h, the first number is the h, and the other first number of the y is the k. So we know that this one is the h and this one is the k, and this is the r. So we have possible answers, this one, and this one, because these ones have for radio 6. Now we need to check for h 8, and this one is the only one that has for h the number 8. So this one is the correct answer. And it was. Let's go to the next question. This was parametric equations. My name is Alejandro, and I see you on the next class.